name's John Green, and you're watching Crash Course World History.
No.
Hi, my name's John Green, and you're watching Crash Course U.S. History.
Still no.
Hi, I'm Hank Green.
Just no. Stop.
Hi, I'm not Hank Green, and you're watching Crash Course Physics, the only crash course where you can throw stuff indoors and not get in trouble.
Yowzers, ow!
In this episode, we'll be talking about projectile motion, as demonstrated by Kermit, which I threw at Mr. Friedman. Projectiles are defined as anything that is projected or dropped and continues in its motion by its own inertia and is influenced by the force of gravity. When something can be identified as a projectile, we can calculate certain characteristics such as how long it will take to hit the target and its maximum height. Let's go to the thought bubble. The motion of a projectile has two parts, vertical and horizontal, which are completely unrelated to each other. We can determine the horizontal and vertical velocities of Kermit by using these two equations and the initial velocity and the launch angle. Let's say Kermit has an initial velocity of 15 meters per second and was released from my hand at about a 30-degree angle. Now using these equations, we can figure out that Kermit's horizontal velocity was 12.99 meters per second, and his vertical velocity was 7.5 meters per second. We also know that vertical acceleration is always negative 9.8 meters per second squared due to the constant force of gravity, and that horizontal acceleration should be 0 meters per second squared since it is unaffected by any vertical motion. Since the horizontal acceleration is 0, we know that the final horizontal velocity will be equivalent to the initial horizontal velocity. The one variable that is always the same is time. If we say that it took 2 seconds for Kermit to reach Mr. Friedman, we can use one of the mechanics equations from the reference tables to determine how far away Mr. Friedman is from me. Using average velocity equals distance over time, we now know that Mr. Friedman had to have been 25.98 meters away from me.
Wow, that's really far.
I know, right? It's amazing, Stan.
I'm not Stan.
So you're Stan.
Nope.
With the information we have, we can also determine Kermit's maximum height. Kermit hit his max height when his velocity was 0 meters per second, because that is when he stops traveling upwards and begins his descent. Using the equation you see, we can now plug in initial velocity and final velocity, which in this case will be 0, and acceleration to determine the vertical distance traveled from my hand. Now, we just have to add the initial height from the ground, which is about 1 meter. And now we see that the maximum height reached by Kermit was 3.87 meters. Thanks, Thought Bubble. So what we've learned today is that projectile motion is divided into two components, vertical and horizontal. To find the vertical and horizontal velocity from initial velocity and angle of launch, how to use the mechanics equations to determine distance and max height, and that Kermit the Frog can be a dangerous weapon.
With great power comes great responsibility. Yowzers!
Greetings, Kermit the Frog here, and today I'd like to tell you a little bit about the color green. Do you know what's green? Well, I am for one thing. You see, frogs are green, and I'm a frog, and that means I'm green, you see? It's not that easy being green.